What I'm trying to do right now is get a pretty good angle so that you can follow what I'm doing with the experiment. So this is lab number 8. What I'm trying to do is get you a good picture of this ramp and how this ramp is set up. Basically, I have the setup all ready to go the way it's shown on the first page of the lab, where I have a ramp and then I've got a board. You can just barely see the top of that fourth line. And then at the end of the ramp, what I have is I have a tape ready to measure where the ball stops. So that's the stopping distance. So the tape stops there at the bottom of the ramp, and then I got 4 release points on the way up the ramp. Now, in this lab, we're going to be using 2 different steel balls. One is for this portion, and then the other one is a smaller one that we use in the projectile, the spring-loaded ball launcher for the projectile motion lab. We're going to be using that again. So I have a steel ball here that I weighed, and it weighs 1.0 ounces. Okay, and if you look at page 2, the first table, each of these blue paint lines that I have on the ramp, on the first page it has release point from bottom of ramp. So the release point up the ramp here is 0.25 meters, so 25 centimeters, 50 centimeters or 0.5, 0.75, and 1.00. So the first column on page 2 for those release points is 0.25, 0.5, 0.75, and 1. Now, each one of these distances up the ramp has a corresponding vertical height from the ground, where it says vertical height, the ball above the carpet. So for the first one, for this 0.25, this height is 0.115 meters. So it's 11.5 centimeters. So 0.115. The second one at 0.5 up the ramp, this one is 0.210. The third one, 0.75 meters up, is 0.305. And this one is 0.40. So working from the bottom of the ramp up, again, along the piece of wood here, along the ramp itself, it's 25, 50, 75, and 100 centimeters or 1 meter. And then it's the vertical heights are 0.115, 0.21, 0.305, and 0.4. Now we're going to measure the distances that this steel ball travels out the ramp in meters, and we're going to do it 3 times for each drop point. Okay, so what we are doing for this first one is same angle. So this board is at the same angle. We're just going with 4 different heights. So 3 trials at 4 different heights. The first trial at 0.25 meters. So this is the first row. So we're at the 0.25 meter line at 0.115 up the ramp. So I'm going to take the ball and I'm going to drop it, and I'm going to measure how far this steel ball went out from the end of the ramp. So it traveled 1.20 meters for trial 1. So 1.20. I'm going to do it again. Same spot. 0.25 up on the here, and it's vertically 0.115. This is my second measurement. And this time, it actually traveled 1.39. 1.39. So we'll do it again. So this is the third trial. And this one, so for trial 3, I'm getting 1.30. So my 3 trials at 0.25 up and 0.115 vertically is 1.2 meters, 1.39 meters, and 1.30 meters. So now I'm going to go to my second tape line and release it. And this one traveled 1.90. 1.90 meters. So second trial. I'm going to call that 1.75 meters. $1.75. So the third trial. So this went 2.1. 2.10. So now I'm going to go up to my third tape mark. This is 0.75 up along the diagonal of the ramp, and it's 0.350 above the carpet. So this is the first trial at my third height. And I'm getting 2.33. Looks like 2.33. 2.33. Third tape mark, second trial. So this one was 2.7. 2.70. Third one. 2.30. 2.30. So now for the last one, we're 1 meter up. We're 1 meter along the ramp going this way. And then vertically, we're 0.40. So this is the first trial at the last height. And I'm getting 3.80. So 3.80. So the second trial, this one is 3.95. 3.95. 395. So this is the last one. This one is 3.60. 3.60. So from those, you can get an average stopping distance. Okay. Now what they want us to do is do different angles, but the same height. So I'm going to need to measure my release point, but I need to come up with a common height. So basically, what I think I'm going to do is I'm going to hold my 40 centimeters here because I just like that height. So on table 2 on page 3, the height, the second column for all 4 rows is going to be 0.40 meters. Okay. And what I'm going to do is I'm going to take my tape here off because these were my heights at the 25, 50, 75 centimeters and then 1 full meter. So now what I'm going to do is I'm going to do 4 different angles, but I'm going to keep the same height. So what I'm going to do is I'm going to adjust the height up just a little bit. Actually, you know what? For the first one, let's adjust it down some. Okay. Let me get some more tape. Get some more tape here, and I'm going to measure where 40 centimeters is to the ramp, and then I'm going to mark it. So that's darn near the very top of the ramp. So it's right there. So I'm going to measure 40 centimeters for each of these heights, and I'm going to let it go. And we're going to see how far it travels. Ball. So let me get my data sheet. And the steel ball. So first angle, so this first row at 40 centimeters height, right near the very top of the ramp. And I'm going to let the ball go. And we're going to go out here and we're going to measure where it stops. So I'm going to call it 5.05. So that first one was 5.05 meters. And it's 40 centimeters or 0.4 meters vertically. We'll measure the height up the ramp here in a second. So we got 5.54. 5.54. Don't know how well the microphone picks up, but it's 5.54. So now, last trial. .32. 5.32. So then you can get an average of that. So the height up the ramp, the release position of the ball, so that first column for this first row of data is 1.210. 1.210 meters. The second column is 0.4 because it's 0.4 here. It's 1.21 up. And my three distances, stopping distances, were 505, 554, and 532. 5.05, 5.54, and 5.32. So now I'm going to increase the angle a little bit, like so. I'm going to pull the tape off. I'm going to measure where 40 is, about right there. And now I'm going to measure up the ramp. So I have 0.915. 0.915. 0.915. And the height is, again, 40 centimeters or 0.40. We'll get three distances. The first distance was 3.87 meters. 3.87. Second one was 4.30. And the last one was 4.45. 4.45. So now what we're going to do is increase the angle again. Figure out where 40 centimeters is. So the length up the ramp, so that first column for this third angle is 0.720. 0.720. So in that first column, 0.720. So the first one was 1.21. The next one was 0.915. Now this third length up the ramp is 0.720. And I'm double checking that the height, the release height, is still staying at 40 centimeters or 0.4 meters. Measure 3 stopping distances. And let go. So that first distance was 4.18 meters. My next one is 3.40. So the second one was 3.40. The last one at that height or at that angle is 3.56. So that row of data should be 0.720 up the ramp, 0.40 vertical height above, and then the 3 stopping distances should be 4.18, 3.40, and 3.56. So one more height, or one more angle, I should say. We're keeping the height the same, right? So increase this up some. I don't want to go so high that the ramp just kicks out. But I do want it high enough that I get a data set that's reasonably spread out. So the length up the ramp is 0.570. 0.570. Double check that I have 0.4 meters or 40 centimeters, which I do. All right. Now we're gonna do my first distance at 0.57 up the wooden ramp, and it's 0.40 of vertical height above the carpet. So I'm gonna let it go. This is my first distance. And I get 2.90. So that first one was 2.90. The next drop. That next one was 2.30. And my last one $2.73. So the last row of data, the release position of the ball from the bottom of the incline is 0.50. The next column, the vertical height, was 0.40. And then the three stopping distances were 2.90, 2.30, 2.73, and all measured in meters. Okay. Now, table 3, for column 1 and column 2, you are just getting that data from, or that information from table 1. So you're just copying that information from table 1 to table 3. But then for column 3, 4, and 5, the velocity of the ball at the bottom of the ramp, the average stopping distance, and the deceleration of the ball. Those you're all going to calculate using the equations that you already know from chapters 2 and 3. Okay, so the last part of the lab, I'm going to reposition the camera. We're going to do the spring constant. So we're going to be launching a smaller steel ball straight vertically into the air and measuring how high up it goes. The reason we're doing that, so see if I can give you a little better angle here. So what I have there is, here's our ball launcher. I'm shooting it straight up into the air, okay? Now, what I have is, it's a smaller steel ball. This was the one I was using on the ramp, and that's the one that I'm using for this part of the experiment. So at the bottom of page 3, it asks for the mass of this ball. So remember, the mass of the first ball on page 2 was 1 ounce, 1.0 ounce. This one is 0.60 ounces, or 0.60 of an ounce. This one weighs a little more than half of the other one. Okay, now notice I'm giving you the measurements in ounces. So you're going to have to convert those 2 kilograms and to be able to do some of the calculations. Now, if you flip to page 4, okay, we're going to be launching this ball at, so the launcher has 3 different clicks to it. And you can hear it as I push the plunger down. You'll hear it click either 3 times, 2 times, or 1 time. Okay. And each time you click it, you're pushing the steel ball further down and compressing the spring more. So when I take a look at page 4, table 4, okay, the first column, number of clicks. For 3 clicks, the spring compresses 6.4 centimeters. Okay, so your distance spring compressed for column 2, for those 5 3-click measurements, it's 0.064. If I'm compressing at 6.4 centimeters, it's 0.064 meters for all 5 of those for 3 clicks. When I depress the steel ball down 2 clicks, okay, down 2 clicks, the steel ball goes down 4.8 centimeters. So the distance the spring compressed is there is 0.048. So column 2, for anywhere that it has 2 clicks, it's 0.048. And then for 1 click, it only goes down 3.5 centimeters. It's 0.035. So the only thing you need then to calculate the potential energy of the ball and the spring energy is how high this ball shoots up into the air. And you can calculate both potential energy, spring energy, and then from those you can also calculate the spring constant. Okay, so you are going to have to watch the videos for that section in the text on springs. You're also going to want to watch the PowerPoint and make sure you understand that before you try doing the lab, because you're not really going to understand what you need to do until you look at that chapter and that part of the text. Okay. So in that respect, you have to kind of look at the text before you can do the lab. Okay. So we're going to measure at one click 5 times how high the ball goes up. Now I have this 2 foot, this is a 2 meter stick. So it's a meter stick, but it's not just a meter, it's 2 meters. So I have the launch point of the launcher at exactly 0.80 meters. So what I need to do then is when I launch this, I need to take the difference between the height that it gets to and 0.8. Okay, so I'll do that with you. So we're going to depress the spring 3 clicks, shoot it up into the air, and see how high it goes. So this is the first trial. That one went 1.98. So 1.98 minus the 0.8 that it started at, the vertical height for that first launch is 1.18 meters. Let's do it again. So the second launch, that one was 1.97. So 1.97 minus the 0.8 is 1.17 meters. This is going right to nearly the very top of this thing. That one went up to 1.99. So your vertical distance on that one is 1.19. That one also went to 199. So it's also 1.19. One more. 3 clicks. That one was 1.97 minus the 0.8, so that's 1.17 meters. Okay, so for 3 clicks, all 3 or all 5 of those, you've got distance the spring compressed is 0.064. So that's for anywhere that it's 3 clicks, the distance the spring is compressed is 0.064. My 5 heights were 1.18, 1.17, 1.19, 1.19, and 1.17 all meters. Okay. So now we're going to do the same thing, but for 2 clicks, we're going to do it 5 times. And then for 1 click, we're going to do it 5 times. So for the 2 clicks, the distance the spring is compressed for all 5 is 0.048. Again, it's the 4.5 centimeters. So we're going to do 3 clicks. I'm sorry, 2 clicks. Sorry, my bad. 2 clicks. So 1, 2, and I was looking higher than what it actually went, so I got to redo that. There's 2 clicks. Still looking in the wrong spot. So that was 150. So if it was 150, 1.50, subtract the 0.8. So that first height is 0.70 meters. Two clicks. I didn't see how high that went. That was 151. 1.51 minus 0.8, you get 0.71 meters. Again, we'll do 1, 2 clicks. We're right around 150. So 0.70. $149, 1.49. So that's 0.69. So this is the last height at 2 clicks. $150. So 1.50 minus 0.8. So you get a height of 0.70 meters. Again, summarize, 2 clicks. Spring, the distance the spring is compressed for all 5 of these is 0.048 meters, 4.8 centimeters. The 5 heights were 0.7, 0.71, 0.7, 0.69, and 0.7, all in meters. So now we're going to do the same thing for 1 click, 5 heights. The distance the spring compresses for 1 click is 3.5 centimeters. So for 1 click, the distance the spring is compressed is 0.035 meters for all 5 of these heights. So we're going to do 1 click and okay. Just want to get an idea of where I'm supposed to be looking here. So that was 1.2. 1.2 minus the 0.8 is 0.40 meters. So it went from 0.8 up to 1.2. So your difference is 0.4. So I got 1.19. 1.19. So you get 0.39 meters for the second one. One click. 121, 1.21 minus the 0.8 to where my target is 0.41 meters. One click. 1.2. 1.2 minus 0.8 is 0.40. Last one, and actually I believe this is the last piece of data. One click, 121, 1.21 minus the 0.8 is 0.41 meters. So to summarize, 1 click, for all of the distance the spring is compressed at 1 click, It's 3.5 centimeters, which works out to 0.035 meters. The vertical height of the ball is 5 trials: 0.40, 0.39, 0.41, 0.40, and 0.41, all meters. Okay, so now the potential energy of the ball, which is the fourth column, the spring energy, and the spring constant, are all items that you are going to calculate. And you're going to put a sample equation to show me how you're getting it. Then take notice that you have to graph. You have to do some graphs on this one in Excel. Okay. And then from page 5 to page 8, there are some questions, some homework style questions. So that is the end of Lab 8, which is conservation of energy. And stay tuned for more, and get in touch with either myself or Professor Donnie or Professor Miller if you have any questions, comments, concerns. Hope you're all having a good semester. I think this is a little more than halfway on the number of labs that we're going to be doing. So keep up the good work. That's the end of this lab. Thank you.